सो हेलो एंड वेलकम टू द ब्लैक होल। आज एक बहुत ख़ास सेशन है मेरे लिए और मेरे स्कूल के लिए भी, जो कि बीकन हाउस कराकुरम कैंपस है। आज हम लोग यहाँ इसलिए आए हैं ताकि हम लोग पाकिस्तान के प्रीमियर साइंटिस्ट डॉक्टर परवेज़ हुद भाई से एक अहम टॉपिक पर जो है वो सेशन ले सकें। और जो टॉपिक का नाम है वो है ओरिजिन ऑफ लाइफ ऑन अर्थ एंड कॉस्मोस। ये बहुत कॉम्प्लेक्स टॉपिक है, लेकिन लेट्स सी कि डॉक्टर साहब कैसे हमें आसान अल्फाज में समझा पाते हैं और हमें क्या क्या कुछ सीखने को मिलता है, हमारे में वो क्यूरियोसिटी का स्पार्क आता है या नहीं। सो लेट्स सी दैट, एंड आई वुड लाइक टू थैंक द ब्लैक होल टीम फॉर इनवाइटिंग अस।
Thank you, Abdur Rahman. Thank you. Just now you have seen experiments performed by Sanan, which were prepared by him and Dr. Sadia Manzoor in collaboration. तो हम कुछ कुछ वक्त के बाद स्कूलों को यहाँ बुलाते हैं हर हफ्ते असल में, ताकि वो साइंस की कुछ बातें सीख सकें। और जो एक्सपेरिमेंट्स अभी आपने देखे हैं, मेरा ख्याल है वैन डी ग्राफ और रिफ्रैक्शन ऑफ लाइट, तो ये फिज़िक्स की पढ़ाई का एक छोटा हिस्सा है जिसको जानना बहुत ज़रूरी है ताकि हम बहुत बड़े बड़े सवालों के ऊपर गौर कर सकें। आज हम जिस पर बात करेंगे, कायनात कैसे वजूद में आई और फिर ज़मीन का कैसे बनना हुआ और फिर यहाँ ज़िंदगी का आगाज़ कैसे हुआ। अच्छा ये बताएं कि आर यू गाइज मोर ओके विथ इंग्लिश और विथ उर्दू? हम दोनों में कर सकते हैं। हाँ, दोनों दोनों ज़बानें आती हैं। चलो, इससे अच्छी बात क्या। तो चलिए आज हम कुछ बहुत बड़े सवालों के ऊपर गौर करेंगे, जिसके लिए मैंने मुझे अपना स्लाइड चेंजर सेट करना है। एक सेकंड। So, we are going to ask very fundamental questions. What is the world made of? Matter, you will say, some people will say, oh, we made of atoms and electrons. लेकिन इसकी भी एक बहुत पुरानी तारीख है. There was a time that people thought, very wise people thought, that it was made of earth, fire, water, and air. And these are the natural elements, and everything else is composed of that. Well, now we have a more sophisticated understanding. We'll get to that. Then, a big question that's puzzled people for ages: what holds up the earth? Look, everything in the world falls down. If I release this, it's going to fall down. All right? And the heavier something is, the more it wants to fall down. So then the question is, the earth, which is so heavy, something must be holding it up. After all, this doesn't fall down if I put it on this table, right? Because the table pushes it upwards, prevents it from falling down. So something has to be there to prevent the earth from falling down. Then, where did we come from? In other words, we who are a part of life originated from somewhere, and what was that origin? The big question is, why are you here? Yeah, I know that this is your school trip and all that, and you wanted to learn about a few things here and there, but why are you here on earth? And then the last question, which will be left as an open question: could there be life in other parts of the universe? Okay, so, the old times had very wise people like Plato and Aristotle and Socrates and many others, Pythagoras, whose theorem you learn about in your geometry classes. The person who first thought of the idea of atoms, Democritus, also belonged to that time. And they had a rather peculiar understanding of what holds up the earth. So there were some variants on this, but one idea was that there is a big elephant, and the earth resides on that elephant. There is another variant, which is that the earth is on the horns of a bull. What's common between a bull and an elephant? They're both big. They can carry huge amounts of weight. And so it was natural to think of some big thing which is holding up the earth. And the elephant is the biggest, but it could have been a bull. And in fact, this was the explanation for earthquakes. When the bull shakes its head, the earth wobbles, and then things tumble down. Well, okay, this has some explanatory power. At least you know why earthquakes come. But then there's the question, what does the turtle, this big turtle on which the elephant is standing, the elephant has to stand on something, right? So there's this turtle which is a अच्छा मस्टंडा किस्म का turtle है. It must stand on something. But then what is that standing on? And so the idea is of turtles all the way down. But then you go down, 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 down. What is that last turtle over there standing on? You have to keep inventing, right? A super turtle. Okay, so that's as far as we can go with the classical understanding. But now we have a very good idea. No, before that, I should say that those were old times. So when was Plato and Aristotle and Socrates? They're about 2,500 years old, and they had their theories of how everything in the world started. And there was also the idea that it was Zeus, the god Zeus, who is the father of gods, he started this whole thing. But then, almost parallel with that, so you have Judaism, you have Christianity. When did Christianity begin exactly? 2025 years ago, 2025, right? That's how we make our calendar. And Judaism is 1,000, 2,000 years before that. Moses, maybe 1,000, maybe 1,500, maybe 2,000 years. Well, between all these religions, which means Jewish, Christian, Muslim, there's the idea that God created it very fast. Islam में तो हम कुन फयाकुन में मानते हैं ना. Well, in Christianity, you know how long God took to make the world? 7 days. And what did he do on the seventh day? No. What did God do the first 6 days and what did he do on the seventh? What did he do on the seventh? He rested. Thak gaya. And so the seventh day is Sunday, which is why you have holidays on Sunday. And I'm astonished. ये चीज़ें तो हमने बचपन में पढ़ी थी और तुम लोग आजकल नहीं पढ़ते हो. मैं नेपाल गया, मैंने यही सवाल उधर बच्चों के साथ किया. मैंने कहा कि do you know why you have a holiday on Sunday? And they didn't know that this was the day that God rested. यार क्या पढ़ाते हैं बच्चों को आजकल? I don't know. Anyway, so God gets all tired out. Seventh day we have this. But let's not be too fixated on that, because the Hindus have a very different way of how the universe came into existence, and it is Brahma. Brahm bhi कहते हैं इसको, and he's the big God. He created the universe. So you see, it all depends on where you are born. If you're born here, you believe in kun fayakun. If you're born there, it's Brahm. But he had competition. Brahm had competition because there's this guy Shiva. Shiv bhi kehte hain isko. So you see, he's got this trident with him, and he comes and he destroys the world because he thinks that Brahm hasn't done a good enough job and there's too much corruption on earth and he's going to just wipe it all out. And so he does. So Shiv is the destroyer, but then after that comes Vishnu, and Vishnu then is a very quiet, peaceful kind of God, and then he creates the world again and he makes it a nicer world. But then the world goes bad, and so then again Shiv has to come in and he's got to destroy it. And so there are eternal cycles. All right, well, we're not going to go any more into that. We're going to go into the scientific view of how the universe and then later life came into being. That means that I have to talk about the Big Bang. And of course, everybody has heard about it, and they think that it was actually bang, a big bang like that. By the way, who hasn't heard of the Big Bang over here? You haven't? Acha. So how do you think the world came into existence? No idea. Maybe somebody can give me some idea of how the Big Bang was conceived, and anything that anybody would like to say over here about the Big Bang? All right. So,
So the idea of Big Bang is कि Big Bang एक धमाका नहीं हुआ था, एक ऐसी चीज़ थी जो एक छोटे से एरिया में काफ़ी ज़्यादा डेंसिटी का मैटर इस तरह मतलब कि कॉन्सेंट्रेटेड था. उसके बाद आहिस्ता आहिस्ता इन्फ्लेशन होने शुरू हो गई थी. वो पहले लोग समझते थे किस तरह धमाका हुआ था, तो इसलिए उन्होंने इसका नाम बिग बैंग रख दिया था, बिकॉज दे डिडंट नो इतना अच्छा कॉस्मोलॉजी का. तो या
okay. So now let's get into a bit of detail. Look, as scientists, we are very limited to what we can see in our world. And so everything in science depends upon observation. Before you can have a theory, you've got to have facts before you. Those facts could be that people who live in rat-infested areas get ill more often than those who live in cleaner areas. That's an observation. But let's come to the relevant one over here. So this is Edwin Hubble. He was an American astronomer. Now he is one of the people वो कहते हैं ना जो अमर हो गए. There's a satellite named after him. There's a space-based telescope named after him, the Hubble Space Telescope. And around 1920, he made this observation which was absolutely mind-blowing. So he was looking at clusters of stars, in other words, galaxies, in this part of the sky, that part, and we can cover the whole sky because the Earth turns around every 24 hours. And so he could look everywhere at galaxies in the universe. Each galaxy has 1 billion or more stars in it. And what he found was all galaxies, without exception, are moving away from the Earth. And further, the greater the distance from the Earth, the faster they are moving. Now, how could he find out how fast a galaxy is moving? You do that by looking at the light that comes through the telescope, pass it through a spectroscope, and then use the principle of the Doppler effect, which is what you learn in school. That Doppler effect is used to tell us how fast cars or planes are moving. But this was long before that time, and he used it in a very imaginative way, and he got to understand that you could measure the speed of a galaxy. Now, his observation is that the galaxy here, and when the Earth turns around this way, there, they are running away from us. Oof. Now that is amazing, because suppose you were to take a video of this, then you would see something going out. And on the other hand, if you were to run that video backward, then everything would be coming together, and come to one single point. And that is when the Big Bang happened. So actually, what you said was true. There was no sound, there was no पटाख, कोई पटाखा नहीं फटा. लेकिन देखो, जब कोई बम फटता है तो क्या होता? बम जब फटता है तो उसका जो मरकज है, उसका जो सेंटर है, वो अपनी जगह पे खड़ा रहता है. जो बाहर का होल है वो दूर चला जाता, इसलिए कि वो सबसे ज्यादा तेजी से हरकत करता. So you see, this sounds very much like the Big Bang, that the further a galaxy is, the faster it is moving. यार हाँ, उसमें से निकाल लेना. नहीं, उस खाने में है. Sorry, my phone is on. इधर लाओ यार, ये पकड़ लो. This right. Of course, you could ask where the center is. Is the center the Earth? Could it be on Mars? Could it be elsewhere in the world? That's an answer that I cannot give until I explain to you how Einstein comes into this, because his theory of general relativity actually predicts an expanding space-time. And if you have curiosity on that, we can talk about more on that. Anyway, so there's this Big Bang. The universe is extremely, extremely hot in the beginning. It doesn't have any of the elements that you see on Earth today. It did not even have nuclei. So there were no protons or neutrons at that time. There were quarks. If you want to know what quarks about, we can talk about that later. There were quarks and electrons and photons. Now, we understand that whenever you squeeze something very, 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 very to very small dimensions, the temperature has to go up. You see that in the case of a gas. When you compress a gas, it gets hotter and hotter. And correspondingly, when the gas expands, it gets cooler and cooler, and that's how you make your refrigerators. So at the very beginning, there were no protons, no neutrons, but after a while, these protons and neutrons were made by the quarks that were swimming around. And then, at one point, you had protons, neutrons, and electrons, and photons. Now, around 1940, which was when the Second World War was going on, there was an astronomer, George, I'm missing his name now, but there was a prediction that if the Big Bang actually happened, then there should be so much hydrogen and helium and lithium, beryllium, boron, and other elements in the universe now. And so astronomers went around looking for that. So the prediction was the world today should comprise of 75% hydrogen, 24.9% helium, and the rest should be just very, very small amounts. When astronomers went around to look, that's exactly what they found. Now see, here is the beauty of science. We didn't have to believe any big person. We look for observation. तो एक observation तो ये थी ना कि ये सितारे सब हमसे दूर भागते जा रहे हैं. दूसरे ये कि जो हाइड्रोजन और हीलियम की मिक़दार है कायनात में, वो उतनी ही होनी चाहिए जितना कि पेशन गोई की गई थी. पेशन गोई क्या थी? 75%, 24.9%, 24.9%, and then the rest will be very, very small, and that's exactly what you find. So then, where did the heavy elements come from? And this is not a prediction of the Big Bang, but this is a prediction of the physics of stars, astrophysics, stellar physics. You know, there's a whole branch of physics where they do nothing except study stars, and that field of physics has become so specialized that you have people studying only particular types of stars. That's a whole lifetime that people spend studying, let's say, supernova, which are stars which end their lives with a big phatte hai. So this is actually a picture that has been taken by the Hubble Space Telescope of a star that lived beyond its lifetime, and ended up spewing out all this matter, this garbage into space. In fact, our sun was made from the explosion of a supernova. It wasn't around just after the Big Bang. But we can spend an entire lecture, 10 lectures, 20 lectures on how stars form, how they die. And of course, there's a very interesting question of what will happen to our sun when it runs out of fuel. देखिए, आपकी गाड़ी है, उसमें पेट्रोल है, पेट्रोल जब ख़त्म हो जाता गाड़ी रुक जाती है, लेकिन सितारों के साथ ऐसे नहीं होता. जब उनका पेट्रोल ख़त्म, मतलब ये उनका हाइड्रोजन ख़त्म होने लगता, कुछ ऐसे हैं जो खामोशी से मर जाते हैं. यानी आहिस्ता आहिस्ता वो उनकी रोशनी बुझती जाती है और फिर आखिर में जाते जाते वो ब्लैक होल बन जाते हैं. मगर कुछ हैं, जैसा कि अभी आपने देखा, जो धमाके से फटते हैं, सुपरनोवा हैं. और सुपरनोवा हैं जिनसे ये सारे हैवी एलिमेंट्स बने, जिससे आप और मैं बने हुए हैं. तो आपके अंदर क्या है? You are not just hydrogen and there's actually no helium in you, lots of hydrogen. Lekin you have a lot of oxygen and nitrogen and carbon and silicon and phosphorus and all that other stuff. Where did that come from? It didn't come from the Big Bang. It came from that supernova explosion. And this is what nuclear physics is, a lot of nuclear physics is about, where you learn how neutrons, so let's take a neutron and a proton, they collide. They make something called deuterium. Then a neutron comes and hits the deuterium, it makes helium, helium-3. Another neutron comes along, it makes helium-4. Then comes a proton. Now the helium can't take any more neutrons. Helium-5 is unstable, it breaks up. And then again, nuclear physics will tell you why. Then comes a proton. The proton comes and it sticks to the helium-3 or helium-4, and you get lithium. And then lithium ke baad beryllium, then boron, then carbon, then nitrogen, oxygen. Pura silsila wahan se chalta, and it only happens inside stars. So guys, there's a big news that I have for you. You are made of stardust. This is what Carl Sagan said so dramatically and beautifully. We are all stardust. We came from the explosion of a supernova some billions of years ago, and it is from there that the solar system came into existence. The sun was formed, और ये सारा जो मलबा था ना, all this stuff that the star threw out, spat out, that is what you and I are made of. And now comes the earth, and the earth is a molten ball of matter. It's so hot that it's hot, but gravity holds it together, and then the heavier elements start sinking towards the center. So we start off with a iron nickel core, which forms first, and then over 4.5 billion years, we go from the supernova explosion down to the formation of the solar system, down to the Earth taking its first form. And that then brings us to the real topic of our lecture, which is life and its beginnings. But before we can talk about life, I need to know what it is. So maybe you can tell me what life is. Anyone want to define life? यार तुम्हें पता है ना जिंदा चीज क्या होती है? You know what life is. बताओ ना. Otherwise, I'm going to pick on someone to tell me what life is. So I better get a volunteer first. बताओ. What is life? हाँ, ओके, इसको चलो, ओके, हाँ,
Something that grows, moves.
okay. It changes. Stone doesn't grow, right?
Yeah.
And
Or
animals do, plants
yes,
do, so they're living. Yes.
living things.
आगे.
Or organisms होती हैं.
Organism क्या चीज होती है? I don't know what. I'm asking you, what is life? Okay, now you tell me. Yes, you tell me what is life. हाँ, हाँ. Okay, tell me what's a good life. कुछ तो बताओ ना. अच्छा, उसके पीछे जो बैठी उसको बताओ. Define life for me. Quick. We have.
Something that respires, grows, moves, and can excrete.
Okay, so it respires, which means that it's got to take in oxygen from the atmosphere. Fine. It grows. Fine. Cats and dogs grow. Plants grow. That's fine. And it excretes. So yeah. Did you all do that this morning? Yeah? Good. But if you excrete, what is it that you must have done earlier? Huh? हाँ, बोलो. शर्माओ नहीं ना, जल्दी बोलो.
Like take in food or ingest something.
Yes. And so why do you need to take in food?
So, for nutrients.
What is nutrition? Nutrition gives you energy. So life needs energy. It needs an input of food which translates into energy. And one thing that you have missed you've missed. पत्थर के बच्चे होते? नहीं होते ना? So you will all produce your own kind eventually. Acha. So actually, let's get a little bit technical on this. So living things need energy. They need to get rid of their waste. They need to grow, develop, and they are sensitive to the environment. So if it gets too hot, too cold, they'll respond to that. They reproduce, and last, and this is the most important thing, they undergo evolution. Now explain to me what evolution is. Who will do that? I know it's tough, but yeah, okay, him.
Adapting.
Yeah.
Adapting to a new form of environment.
Right, correct. Can you develop on that?
If you have an environment that's not suitable to you, you adapt yourself to it and find a way to evolve from what you were before into a new version.
That is correct. But you cannot do it, I cannot do it. But organisms over time, they will create offspring, and the offspring which manage to adapt to the environment will survive, and those which cannot will die out. Can you give me an example of that? A very recent example. Well, let me give it to you. Abdul Rahman, you want to say something? Yeah.
So I don't remember the exact details, लेकिन black moths का और एक white moths का कुछ था
Beautiful.
written में
Beautiful.
industrial evolution के time पर कि जो black moths थे वो इसलिए हो गए थे क्योंकि इतनी ज़्यादा pollution होती थी and they like couldn't.
Okay, so you're talking about London in the 1850s, around the time of the Industrial Revolution, and I'll briefly summarize what he's trying to say, and it's a very important example. वैसे जो बात इसने की है ना वो तो हमें हमारे स्कूल बुक्स में कभी नहीं पढ़ाई जाएगी बिकॉज इट इज़ एविडेंस ऑफ डार्विनियन एवोल्यूशन. डार्विन का नाम लेना जैसा कि कोई बड़े शैतान का नाम लेने के बराबर है, तो इसीलिए आप लोग जो हैं एवोल्यूशन पढ़ते नहीं हैं, आपके लिए कुफ्र है. डार्विन ने ये कहा कि कि एक जानदार जब उसकी औलादें होती हैं तो उनमें कुछ म्यूटेशंस का आना, थोड़ा सा फर्क का आना मुमकिन है। बहुत से म्यूटेशंस ऐसे होते हैं जिनसे जब वो जानदार बड़ा होता तो वो फिर उस एनवायरनमेंट के हिसाब से चल नहीं सकते और वो ख़त्म हो जाते हैं, लेकिन जो उसके हिसाब से चल सकते हैं उनकी तादाद, उनकी नस्ल बढ़ती चली जाती है। तो ये डार्विनियन एवोल्यूशन का मजबूत उसूल है कि only organisms that can adapt to their natural environment will survive and thrive and reproduce in large numbers, the rest will die out. और इसकी एक इतनी खूबसूरत मिसाल कोविड-19 से मिलती है। तो कोविड-19 का वायरस कहीं से शुरू हुआ, who knows where, whether it started from China or whether it started from Africa, we don't know. But after a lot of research, it was found that there's a vaccine called mRNA vaccine, and that vaccine was very effective and probably saved many millions of lives. But then every virus produces its own kind in huge numbers, but somewhere along the line one of those has mutated, मतलब ये कि उसकी शक्ल और सूरत पहले से बदली हुई है और उसको mRNA वैक्सीन नहीं मार सका। लिहाजा अब मुख्तलिफ स्ट्रेन्स, मुख्तलिफ इक़साम कोविड-19 की मौजूद हैं, अब भी दुनिया में हैं। और ये ड्रग्स में एक बड़ी नोन चीज़ है कि ओवर टाइम you will have adaptation, and so antibiotics is a wonderful example of that. पहले तो एंटीबायोटिक्स है ना, सारे आपके जरासीम जो है मर जाते थे, लेकिन फिर कुछ जरासीम हैं जिनके बच्चे अडेप्ट कर गए उस एंटीबायोटिक के एनवायरनमेंट में, उनकी जो नई इक़साम निकली वो एंटीबायोटिक रेजिस्टेंस है। सो I am stressing this because Darwinian evolution is the fundamental basis of biology. And anyone who teaches you biology without teaching evolution is committing a crime. And that is why Pakistan has produced no biologists of any repute. अच्छा, तो हाउ डिड लाइफ स्टार्ट? अब देखो, जो पुराने ज़माने में ना पुरानी थियरीज थी, तो एरिस्टोटल तो समझता था कि ये दरियाए नील से ये कीड़े मकोड़े जो निकलते हैं और ये छिपकलियाँ और सांप और इंसेक्ट्स के ज़िंदगी का आगाज़ वहाँ से हुआ और इसीलिए नाइल को पूजा जाता था. इट वॉज द रिवर गॉड विच वॉज वर्शिप्ड इन दोज डेज. By the way, the English had the best explanation. They thought life comes from the dirty underwear of kings. Well, who knows? After all these are non-scientific things. What we want to do is talk about science. So, let's go to the beginning of the early days of the earth, when you had nitrogen and water vapor and sulfur dioxide and lots of this very stinky stuff in the atmosphere. Methane in particular. Has anyone smelled methane? Well, okay, just that's what comes from poop. Lots of hydrogen. And this is what the early Earth probably looked like. So this is an artist's impression. It's volcanoes that are spewing out huge amounts of sulfur dioxide. There's sulfur springs. There's above all, there's this lightning. The amount, if you had been alive a few billion years ago, the lightning you would have seen would have been spectacular. अभी तो कभी-कभी नजर आती है ना, जब कोई तूफान होता, उस ज़माने में there was a huge amount of lightning because all that energy that was received from the sun had to be given to the atmosphere. The atmosphere would create that into electrical energy, and so you would have these huge amount of lightning. And so that means there was a lot of energy to work with in those old days. So scientists had been thinking for a long time that, okay, we have a picture of the Earth as it was in its early days, but then how do simple atoms like hydrogen and oxygen and even molecules, nitric oxide, sulfur dioxide, how do you get life out of them? ये तो बेजान atoms or molecules हैं. And so that is the big question in the chemistry of evolution. The first step of which was taken in this wonderfully simple but the earth-shaking experiment, I'd say. No, earth-shaking to nahi, lekin it was excellent example of chemistry used for this purpose. So 1953, there are these two guys, there's Miller and Urey, and they were actually building on an idea of JBS Haldane. Haldane का किसी ने नाम सुना? You have. अच्छा, in what sense बताओ? नहीं, if you have heard, किस तरह से? हाँ, I'd be very interested to know.
I read it once in a book.
Okay, so you just have a vague recollection. Actually, Haldane used to be at FC College in Lahore. He was a brilliant chemist. And but somehow he got fascinated with India, and he spent a lot of time moving around, and for some time he came to Lahore also. Anyway, here is the experiment. So there's a Bunsen burner here, there's water vapor here, there's water here. The water gets heated, it goes up that pipe, and then it comes to this top place over here, where the reaction chamber is, where you have a mixture of methane, CH4, ammonia, and hydrogen, and then you have over there two electrodes, and those electrodes are at a very high potential, so they cause a spark to go across, just as happens in your car or your motorbike. And that spark does what? It gives energy. That energy then allows the transformation of simple atoms into more complex molecules. And what's the spark supposed to simulate? The lightning, yeah. So they're trying to create the conditions of early Earth in the lab, and what they find is, okay, so before that, then the water vapor goes there, it goes through the condenser, so the water condenses, and when it's condensed, then you take the sample that's condensed off to the lab and you analyze it for any products that have been formed. The big discovery was that they found amino acids. Has anyone heard of amino acids? अच्छा, बताओ क्या है? कुछ हाँ, you shook your head, so यार उधर ले जाओ ना. तुम लोग शर्माते बहुत हो.
So basically those are organic compounds that have NH2 and carboxylic group attached to both the ends.
See, he studied organic chemistry और फिर भी हिचकिचा रहा था. Yeah, and what's important about amino acids?
So basically they form polymers.
Yeah.
Which have amide links. So they are found in nylons and proteins.
Excellent. How many types of amino acids are there?
21, I believe.
20, exactly 20, yeah. Why we have only 20 is still being studied in chemistry, but yeah. We have 20 types. They make proteins and they make fats and all kinds of complex molecules. And so this is how the first RNA was formed. Now from amino acids to RNA is a long way. It's something that people are presently still trying to understand. But then from RNA, eventually you get to DNA, the stuff that you have in you and which you will give to your children and their children will give to their children, and which is the basis of all life. So once the RNA is formed, you have the first living organism on Earth. It's called a prokaryote. And the prokaryote is, you're shaking your head, so you know about it. So tell us about prokaryotes. ये तुमने biology में पढ़ा है. हाँ. अच्छा, who will tell us about prokaryotes? Anyone? यार तुम्हें इतना पता, तुम ही बता दो. अच्छा. And okay, so these are living. By the definition of life that we just saw, that is, they need energy, they excrete, they reproduce, they move, but they were so utterly primitive that it's just the very beginning of life. You know, we think of a virus as being a living creature too, but these are even more primitive than viruses. Well, then comes the age of eukaryotes. So, anyone know what mitochondria is? Yeah, okay.
Mitochondria is the powerhouse of the cell.
Yeah, okay, fine. And the cell wasn't around. We're getting to the beginning of the first cell. But yes, mitochondria were the chemical assistants which helped produce that first cell. And the eukaryote, which comes at the very next stage of evolution, is different from the prokaryote in the sense that it has a nucleus and it is a cellular organism, which means that it has a wall, it's got DNA inside, very simple of course, but it's got DNA, so it's self-replicating, and it now is going to be around and producing more and more of itself, the numbers only being limited by how much energy it can get, how much nutrition it can get from its environment. And so now this is really the story of life itself. And look how, I don't know if you can read it all from here. So 4.5 billion years ago is the origin of the Earth. So down there at the very bottom, then the Earth eventually gets cool enough so that at least the crust solidifies. And that's the formation of land. And of course the continents were looking completely different in those days. Then around 1 billion years after the Earth is formed, so 3.5 billion years ago, you have the oldest prokaryotic fossils. What's a fossil, by the way? Anyone know what a fossil is? Yeah, you put up your hand. You did. What is a fossil anyway, you tell me? कुछ तो पता होगा ना? नहीं? अच्छा, हाँ, उधर उस, what's a fossil?
The remains of early organisms.
The remains of?
Early organisms.
Of?
Early organisms.
Of any organism. Okay. So, do you have an idea of why those remains happen to be there in spite of the passage of billions of years. You know, there are fossils. I mean, when you die, you'll probably be buried in Islamabad H8 graveyard. And your remains will disappear after a few dozens, maybe a few hundred years. And then no trace of that left. Then absolutely gone. On the other hand, these fossils, some from, well, the age of the dinosaurs was just 50,000 years ago. We have fossils from there. But we have fossils from billions of years ago. How is that possible? The answer is, sometimes there are just pure accidents of nature, and some organism happens to die and is surrounded by a crystal or some growth which totally forbids the entrance of water. If water is taken away, then the organism cannot change its state. And so, if the conditions, physical conditions are right, if it's very, very cold, if no gas, no water vapor can enter the space around that dead organism, then it's preserved into eternity, forever. So that's when we had, so you see the oldest fossils are here. And then after that, evolution, yeah.
I have a question. Alright, so आपने कहा था कि क्रिस्टल के अंदर वो रिमेन रहेगा उसके फॉसिल्स, ठीक है. मेरा सवाल ये कि क्या डीएनए भी फिर प्रिजर्व रहेगा?
Yes, absolutely. So we have the DNA of the early eukaryotes. We have the DNA of the dinosaurs. Jurassic Park देखी है ना तुमने?
यस, लेकिन मैंने देखा था कि वो पेलियोंटोलॉजिस्ट कह रहे थे कि डीएनए मतलब इस तरह बिखर जाता है, तो हम लोग
Yeah, because it is very rare that something gets preserved. Something may last for 1 million years, but it may not last for 2 million years, because it all depends upon where that organism dies and how well preserved that DNA is. Dekho, you take a DNA from a crime sample here. It's fine even without refrigeration for, I don't know, some days. With refrigeration, it lasts some months, maybe years. But eventually, that also will get affected by the environment. So it's just great luck that a paleontologist comes along a perfectly preserved DNA sample. Right, so then we get into protists, plants, fungi, animals, and of course we are all animals. We are mammals. We share many common features with mammals. But, my saying so doesn't make it true. What is it that you have in common with a cat?
Hair.
Okay? Or kya? Yeah, bolo.
Can reproduce.
Yeah?
And
You haven't reproduced yet, but you will. Okay. Aage?
we can
Yeah.
see, eat,
Yeah?
uh,
Good?
move,
Move,
expire.
respire, expire, everything. Yeah? What is the temperature? What is your body temperature?
core temperature is 37
नहीं
degrees.
तुम्हारा what is it today now?
Don't know.
ये बीमार तो नहीं हो?
नहीं,
तो फिर कितना है?
37.
Yes, good. बिल्ली का कितना है?
37 ही होगी.
Yeah, actually just a little bit more than that. Look, if we were different from other mammals, our body temperature should be totally different. You want to take the body temperature of a snake, of a lizard, of a mosquito, of a fish. This is nowhere close to 37. So there's something very, very important that connects us, all mammals. वो दूध पीते हैं, उसके बच्चे दूध पीते हैं, हमारे बच्चे भी दूध पीते हैं. So our affinity with the animal kingdom, and in particular the mammals, is just incredibly close. And it's surely not accidental. But if you want to get still closer, you don't look at dogs and cats or elephants, you look at apes. So where are the apes? I had them here. Where? Oh man, I missed. Here. From a variety of apes, here is where we came. So up the evolution ladder, the tree of life, one of those, actually, it's not that we came from apes. It's that we came from this general genre. And all these technical names over here of lemurs and tarsier and seabird and macaque and ape and human, these all, they all come back to the same starting stem, which is why this is the tree of life. This is why all life, whether it's humans or mosquitoes, we owe to the same origins. And this is what makes this so difficult to swallow for some kinds of people. Well, let's go ahead. All right, now, numbers always leave people confused. How to digest these big numbers. So when we say that prokaryotes started 3 billion years ago, that's a long, too big to understand. एक किस्सा मैं सुनाऊं. आज से कोई 50 साल पहले हम एक गांव जाते थे और गांव से फिर हमें एक स्कूल तक जाना होता था. तो हम लोगों से पूछते थे, ओ जी कुआवा कितनी दूर है? ओ नेड़े ही है जी, नज़दीक ही है. अच्छा, घंटे के बाद चल के थक हार के हम पहुंचते थे. कोई और रास्ते में मिलता, उससे भी यही सवाल पूछते थे, ये गुआवा कितनी दूर है? ओ नेड़े ही है सर जी. So the point is that people who are not trained to think quantitatively, they say नज़दीक ही है. In fact, there's a book by George Gamow. It's called 1, 2, 3, Infinity. So, some animals, and some humans, they can't think quantitatively. They can only think up till a certain level. The only bird that can think quantitatively is the jackdaw, and it can count up to 7. But we humans have the ability not only just to speak, but to do mathematics. And that's what makes us so different from the ape and everybody else. But still, 3 billion is very hard to swallow, digest. So in fact, that's why I said I will make a little explanation for you. Suppose the earth started at midnight, 12 a.m. Well, the earth was so hot and the conditions were so bad that there was no possibility of any kind of life. So until 6 in the morning, there was nothing, absolutely nothing. And then come the prokaryotes, which we've discussed as being the most primitive forms of life. That's from 6 in the morning till 4 in the evening. And then the eukaryotes, 4 to 10. Then come all the multicellular organisms, the fish, the snakes, the birds, and so forth. And we humans are in the just one last minute of evolution. That's telling you how recent, how new we are on Earth. Well, that's what we probably look like. You can recognize pretty much everything over there. Mother, child, nurture. There's the hunter. And our forefathers used to look like this. Now, I'm not ashamed. I don't know why people are ashamed when they are told, your father's father was a monkey. Okay. If he was, so be it. I'm not going to be ashamed. This is what science tells me. This is the way it happened. Whether you're proud of something or ashamed of something, that's up to you. That's entirely your personal business. But this is what science tells you. That's where we came from. I just have a couple of other things to say. One is, some of us think we came from Arabia. कोई सैयद हो जाता है, क्या क्या नाम लगा देते हैं, हम रसूल की आल से हैं. ठीक है, होंगे ज़रूर, मगर वो कहाँ से आए? We all came from Africa in a major migration 60,000 years ago. And the evidence for that is as strong as the evidence that the planets move around the sun. And how do you do that? Because now we have DNA. With DNA tracking, we can plot every bit. We can plot every bit of this migration, which you can ask why this migration took place. Basically, it is that Africa, which was a very good place for humans to live in those days, suddenly not suddenly, but over time started changing. It changed from being so plentiful with fruits and animals, wild being hunted, and so people moved out of there, and eventually they went across the globe. This is so important politically. It's not just that you guys are so proud of being Sayyids and all that, but the Hindus, they're saying that we are people who have always lived on this land and we've been here since the beginning of time. Nonsense. They came. Whoever inhabited India actually came from Africa, and then over time we evolved and became different and different. So I'm pretty much done. Are we alone? It's certainly the case that there's no advanced form of life anywhere in the solar system. Anywhere in the solar system. But could there be life outside the solar system? Answer is very probably yes. We're not going to be able to talk to them because they're too far away. And so that's pretty much it. Just to summarize, you can't argue against the Big Bang. There's too much solid evidence, and I've not had time to give you enough we don't know as much about the solar system, but we're learning more and more. And we're pretty sure that life originated on Earth, but we are not absolutely sure because it could have come from outer space, because outer space is where complex molecules can also be formed. And finally, the fifth point over here, whatever explanation you have, without Darwinian evolution, don't study science, don't study biology. Okay, done. Questions, quick questions. Something that's really working you up. और ले लेंगे यार, pictures तो होते रहते हैं, but लेकिन tell me what is something bugging your mind. If it's not bugging your mind, then come have a picture.
Sir, what was the motivation for you to study science?
Everybody's motivation is different, but I wanted to understand electricity, and then that sort of just, I went a little crazy thinking about electricity, and then I went to MIT and I thought I'd do electrical engineering, and then I saw physics and math being much more beautiful, and so that's how I got into that. But everybody has a different pathway to science. Acha.
सर एक क्वेश्चन है, देखें आपने बोला था कि जो संडेज और सैटरडेज और संडेज वीकेंड वो रेस्ट डेज हैं, मगर वो गॉड है ना जिसने ज़िंदगी बनाई, वो किस तरह थक सकता है?
यार इतना बड़ा काम करने के बाद थक नहीं जाएगा?
सर मगर वो गॉड है सर.
Well, God is capable of making a stone so heavy that he himself cannot pick it up.
सर पर ये तो वो बात होगी कि आप कितना चला रहे हो और आपको पता ही नहीं है कितनी आप सुन रहे हो उस डेसिबल्स को.
बस अब मैं क्या कह सकता हूँ, थक गया बेचारा.
ओके.
आ जाओ तस्वीरें निकाल. अच्छा, ये वन लास्ट क्वेश्चन है. हाँ जल्दी.